Okay, can you hear me now? Can you hear me now? Okay, cool. All right. All right, can you hear me now? Oh, that's gonna be a problem. Yes, unfortunately, my headphones are problematic. Okay, so I'm gonna. Oh, I think it's. All right, can you hear me now? Oh, I think I see what's going on. Okay, all right. So I'm just gonna call on people in the order in which I see them and just answer questions. Bo Yuan. Bo, do you want to ask a question?
I'm just trying to listen in to see
Cool.
what questions people have.
So whoever wants to ask a question, maybe they can raise their hand. I know, or there's not very many people right now, so just speak up. Okay, yeah, Rima, yeah.
Okay, so I had a question about the 2021 midterm. I was looking at question 1.
Okay.
And so I had an alternative answer and it was still working. So my question is, if we do have a code that isn't at all similar to the mark scheme, but it still works, will the points count?
If it works, it works, right? So the question is like a contract. If you say what the question asks, we're not that. So unless we're asked, sometimes we would ask for a specific method, and then you have to follow it. If we don't ask for a specific method, as long as you do something that works, it's okay.
Okay, and also in the 2020 midterm, I noticed it was one of the most challenging midterms. I assume it's because it was online and so on, but I was looking at question 5 and I really couldn't understand the answer or even how to proceed.
Yeah.
So can we take a look at that?
Yeah. So challenging. So the thing about it is it was obviously open book and it was with the help of a compiler. So it's not really the same. Whether it was challenging or not, it's so whoever's waiting, sorry, are you waiting for me? I'm just over here. Yeah, so they're gonna open thing at some point. Yeah. So okay, so you're asking about question 5, I guess. So it says matrices can be represented as lists of lists. Write a function that takes in 2 matrices, size up n, return true if the matrices have at least n minus 1 of the same column, right? So what this means is, for example, for M1 and M2, so this column and this column are the same. And then I guess this column and this column are the same. So there is 3 columns in total, and out of those 2 are shared. So that means that it should return true. So does the question make sense?
Yeah, I just know that we need to use a loop inside a loop, and I don't know how to do it.
Oh, so I wouldn't do method first, as opposed to kind of a solution first. So so here's how it would start. So save it. So. And I'll do maybe a different thing. So here, it's is it M1, M2 or something? Yeah, I guess, yeah. So the first thing I'll do is I'll do something easier. So I'll do 2 lists of length n. Oh, this is annoying. So I'm doing 2 lists of length n, and I'm asking, do they share n minus 1 entries, right? So I'll just do that before I get to columns. And that's the general problem solving strategy that you should use, is what's something that's similar but simpler that I can do, and then expand from there. And it wouldn't be maybe the complete thing if you write it out on paper, but you'll start the idea, right? So, okay, so I'll say share in 1 lists, and this would be L1, L2. So what I'll do is I'll start with just writing some examples. So 5, 2, 3, and then this would be whatever, 2, 5, 1. So here the answer would be true, right? So how would they know that the answer is true? Well, one way to do it is to just go through the entries of L1 and ask, is this entry in L2? Is this entry in L2? Is this entry in L2? And then count up how many matches I have. And if I have n-1 matches or n matches, then I'm done, right? So, okay. So I'll say for E, so I'll say count matches initially is going to be 0. And I'll go, yeah, that's actually pretty good. So I'll say for E in L1, and I'll say yes. So if E is found in L2, then counting as then I'm adding 1 to the matches. And then at the end, I'll just say, so this is N1. So really I need like return count matches is greater or equal than length of L1 minus 1. Right? So this would be true if the number of matches is n minus 1 or n. And that's what I need, right? So, okay, so that's integers. Now, what we have is columns. So columns are kind of annoying because, like, you can't really do this kind of thing with columns. Except you kind of can. You just need to write functions that are similar to what we had done this week in the lab, right? So I can just say, let me get column number I. And this would be M, and this would be I, right? Well, you can do it like that, but we don't have it. So I'll say like column is initially empty. And yes, so I do each row in M. So each row in M, if the matrices are like this, so for row in M makes it so that the row first it's this guy, and then it's this guy, and then it's this guy. So I'm saying for row in M, and I'm getting row at I. So I'm getting element number I from each row. So if I is 1, I'm getting this element, and then this element, and then this element. So, okay. So that gets me a list, which is column number I. So now we have the equivalent of being able to say for E in L1. We can now get column 0, column 1, column 2. And now we also want to be able to check whether the column is in another matrix. Okay. So I'm giving it the matrix M, and I'm giving it the column. And here, yeah, that's a good suggestion, right? So here we're saying for I in range length of M. So length of M is, well, so here, this is not actually correct. So we want length of M at 0, right? So we want the length of the row, that's the number of columns. And now we're just saying if the column is the same as the ith column of M, then we found a match, return true. If at the end we haven't found a match, we return false. So, okay. So now that we have those two helper functions, we can just proceed to write this. So what do? Well, we try every column in M1. So this is again wrong. We get the column. This is completely wrong. So we get the column, and then we check whether it's an M2. So count initially is going to be 0. So it's same as before. And now we check if the column is in M2. And if it is, we can't match it. We increase the count. And same as before, if count matches is greater than the number of columns minus 1, we're done. All right. So the general problem solving strategy here is you first say, okay, like what's the simplest version of the problem that I can kind of solve? And I think this is like not that difficult, or like, at least kind of like compared to the original question, this is not difficult. Right. And then you say, okay, so we know how to do this. Now, how do we expand? Okay. Well, yeah, we're waiting for someone to open the door. So in the meantime, we're just here. Yeah. All right. What extension am I using? So I'm using GitHub Copilot. All right. Anyone else have questions? Yeah. I mean, I think so like it's a little bit of a subjective question.
Yeah.
So I would say you can look at previous midterms and decide for yourself what the difficulty level is for the previous midterms. Now it varies year to year. And part of it is kind of like it just naturally varies year to year. Like you make up some question and it turns out to be easier than you thought, and sometimes you make up a question and it turns out to be more difficult than you thought, and then that's why usually scores are adjusted, either for the midterm or like at the end of the semester. Sometimes not, like it's not guaranteed, but a lot of the time there are. So in terms of, you know, kind of the answer is like usually at the end, kind of the marks are like between like the low 70s and the high 70s at the end adjusted.
And
so yeah.
because English is my second language,
Yeah.
so sometimes like I don't understand the expressions.
Yeah.
Because the coding, but it gives some examples, so I
Yeah.
don't understand by like
Yeah. Yeah.
I don't know how we turn.
I mean, it's not going to be that different from what it's been before, I would say.
Like on this turn, if I understand.
Certainly, like you can always ask now. Like sometimes we kind of refuse to answer during the midterm, but you can always try to ask. Yeah. So like I think it also makes sense to just like develop strategies for kind of figuring out what the question is. So if you like, we can kind of do like if you can point to an example where the wording is unclear. One, maybe I could improve, like learn from that how to improve the wording. Two, maybe I can suggest strategies for how to read it. So do you have an example?
Like,
Yeah. 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 No, yeah. So I mean like an example of like where the wording, where you think like the wording would be unclear.
Oh, there's an example like if you could sleeping we are not waking.
Is it unfolding that?
We-
Yeah. I mean, like I would also say that kind of if there are examples, like the person who's writing the question like knows there's going to be examples. So maybe they're counting on the examples to make things clearer. So you can't just take something in isolation where the author actually had examples, but we can try to read it. So the parameter weekday is true if it is a weekday, and the parameter vacation is true if we are on vacation. We sleep in if it was not a weekday or we're on vacation. Return true if we sleep in. Yeah. I mean, so this question I don't really like very much, to be honest. So I think what they mean is actually just So they just mean this. So it's kind of like directly, you can just directly translate it to Python. I don't think it's a great question, to be honest. But yeah, like they're definitely also counting on the example, kind of demonstrating what you mean.
Do you mind like go through like a few lecture I didn't understand, like for like random stuff, tracking the X?
We can do that. Yeah. Yeah. So okay. So let me. I think the work. I'm not sure kind of who's in line first. Yeah. So let me quickly answer kind of the question in the chat. So when writing a midterm, are arrows okay to show intent? Sure. Yeah. Like as long as you're clear about what you're doing, it's all fine. Just like be reasonable about it. All right. So I guess the question was with the random, right?
Yeah.
So okay, so I'll do random and then I'll do I guess global local. So the basic idea is so you can do kind of like next random. So like something like this, right? So in fact, I don't want it like this. So we're basically kind of updating a number. So we start with some kind of seed. So maybe we start with like whatever. And then we're saying change the seed like this, right? So make it be whatever, something new. And then return the new one. The way, so I'll go back to how to design it, but kind of the way you use it is you say, it's not relevant. So you say something like print next random number, and then you do like print next random number again, and then what's going on? And then you run it and you get like, first you get something like this, and then you get something like this. So it's like a new random number every time. So that's what we're going for. So
this number you get here on the seat, you just put it like random also, right?
well, so nothing here is exactly random. Oh, you mean like the constants?
Yeah.
Yeah. Well, so like you choose them in a way that you get something nice. So in general, what you want to do is you want to multiply by some prime number and then mod with some other prime number or something like this. But there's flexibility there, like basically any numbers that you put in that you just like randomly bang on the keyboard is going to give you something, right? So like you multiply by a very large number, you get a huge number, then you do mod another number, so you get the number between 0 and the number that you mod by. Does that make sense? So you start with like seed equals whatever. And then if you do seed times a very large number, you get a huge number. And then you do seed times this number, mod whatever else. What you get is some extremely large number mod this. So that's going to be something between, so it's going to be something between 0 and this one -1. Right. And you do it again, and then you mod again, so you get some other number. Right. So you get a sequence of like random looking numbers, basically, if you repeatedly do this. So in terms of the implementation, what we need is we want to get a new number that's returned from here every time, right? So at first glance, it should look a little bit weird because like you're calling a function, but you're getting a different number every time. So the way this is accomplished is by saying, we'll look at the global variable seed and we'll modify the global variable seed every time and we'll return the new one. So an easier version of this is what we had done in lecture. So if you just do counter, right? So what happens here is the job of counter is to increase seed by 1 and then return seed. So if you call counter several times, so I'll do like seed is equal to 0, and then I'll like print counter, print counter, print counter. So what happens? Unexpected indent. Looks fine to me. So you got 1, 2, 3. So why is it 1, 2, 3? Well, because you set seed to 0, so now seed is 0. And then you say, I want to call counter. So you go from here, you say increase this seed by 1 and return the new seed. So return 1.
This seed, put it here in the global.
That's right.
But we don't need to write global.
Global. So
Oh.
anything that's outside the function is global,
Oh, okay.
right? So does that make sense?
Yeah.
Yeah. So then like pseudo random is just the same as it's just that instead of saying seed plus 1, we're transforming seed in this way so that we get some new random looking number.
And what is the random dot? Like, is there any difference?
Well, so that's just like the Python built-in implementation of this kind of thing.
So, okay, that's it. Is the same thing with import math.
Yeah, so random is another module, like math is a module. Yeah,
So if we import math, we could do like math of pi, so we could get the pi number.
that's right.
If we do we need to type import random or just
Yes,
import random and then
random dot random. Yeah, so you can do something like import random and then here you can do like print. Oh, are you here to open?
Yep.
Cool. So it's 1190.
Yeah, I'm good.
Oh, cool. Thank you very much. And then if you call it several times,
oh, so random is between 0 and 1.
that's right. Yeah, so here kind of for simplicity, I didn't do the 0 between 0 and 1. Now, this expression, it's always between 0 and this much minus 1. So that means that if I return seed divided by this number, I'll get something that's between 0 and 1 as well.
Oh,
Cool. All right, so I think the next question was about global and local. And like, honestly, I think it might make more sense to watch the lecture if you want like a full introduction to global local. But I'm answering questions from the chat, by the way. But so we can kind of try to have a discussion as well. So how much do we need to know about matrices? I mean, you don't need like all the information that you would need about matrices would be provided to you. Nothing beyond what you had done in the lab last week. What I would say.
For that, I have a question. Like, I don't know.
Yeah, sorry, I'm answering kind of global local. So yeah, so I think we kind of already had a bit of a discussion about global local. So the basic idea is so I'll refer you to the lecture, but also like if you have questions, feel free, because like if we do something interactive, that might be better, right? So if you have a function, anything, so f of x, sorry, so we're moving inside the lecture hall now. Thank you, sir. Oh, that was open the whole time.
This prop open all the time. Oh, good luck. Anyone else?
Yeah, can we, is there a chair there? Or there's a chair here. Yeah, so I guess we'll just go to the first row for now, because it's just the three of us in person, and then or I think I lost like 10 and I won like 3 or something. Well, that might, so that might be an exaggeration. I might have won, I definitely won 2. I think I might have won 3. But yes, I owe the charity $78. But yeah, it's on YouTube. You can watch it. Yeah. I mean, I was humiliated a little bit, so I might delete it later, but for now it's not. But yeah, I think it was just like the people who live in residence who showed up. So like maybe we'll do like another one on a weekday or something. And I got to find it because I know that Natalie, the director, also played, and I got to find out how she did, like if I did like much worse than her. So okay. Yeah, so okay. So we're back. So if you have something like this, so the two situations where the variable is local is if you just say something like this, for example, like y is equal without saying global y, or if it's a parameter. So both x like this and y like this would be local. So local means that those numbers just exist inside the function, right? So if you say something like f of 5, you cannot access x, and you cannot access y either. Of course, you know that y happens to be 5 in this case, but you cannot access it, right? So both x and y just exist while the function f is running. right? So what you can do is you can say that Z, for example, is global. And then you can set Z to whatever you want, like X plus Y. And we can access that Z. So I can say, for example, print Z, and that will print the value of Z to whatever I set. Okay. So that's the answer. That's the essence of it. Now, where it gets a little bit confusing is if you say something like X is equal to 56, and then you say like f of X or something, you might be misled into thinking that, oh, because this is X and this is X, that this matters. It really doesn't. So this X is separate from this X. So this X exists while the function is running. If this X is the global X, it's not to do with the local X, except they might be equal, but that's the extent of it. But like the reason they would be equal is you just say f of X, so you send the value of X here to the value of X here. This is just as if you said f of 56 happen to be equal, but otherwise they don't have to do with each other. So that's the confusing part, and everything else I told you. Yeah. That's correct. So you can, so if you say global X over here, that would just produce an error. And that's because if X is a parameter, then it's by definition local. You cannot make it global. Okay. Well, no, so that's different. So, so this is, I think what you're asking about is this kind of thing. So when you're saying f of X, you're just sending the value of X. So this is exactly the same as f of 56. And like, of course, if you say f of 56, that's nothing to do with X, but f of X is exactly the same as f of 56. You're just sending the value. You're not saying, oh, this happens to be X, not relevant. Well, at least in this case. Yeah. So I should say, like, there is like, there's subtleties there when you start working with lists, but we haven't done that in lecture yet. Like so far, like f of X is like not different from f of 56. So that's that. And like the other thing I would say is like you can think about it as having several ways of so several ways of interacting with a function, right? So you can send the function f information via arguments. So for example, f of 56, so you're sending it the information, I want you to do something with 56. Or you can send it information via global variables, like the value of Z, right? So here I kind of change it a little bit so that Z, let me make it explicit, Z is Z plus X plus Y. So here, well, how does the function know what the value of Z was in the first place? Well, it's a global variable, so it can access it, right? So here I'm both sending the value 56, for example, as X to F, right? So like this 56 gets sent to this X. But another way that the function F gets information from the outside world is it knows what the value of Z is because Z is a global variable. So it just looks up what's the value of Z. Sam? Why? What's 1, 2, 3? Yeah. Well, yeah. 123. Yeah. Well, it doesn't really do anything in this case, right? So it just updates Z to be Z plus X plus Y in this case. Yeah. So like, we can just do it. So like, if you print Z now, it's going to be a new value. So 308, I guess. Sure why it's, oh, because I did that for 5 before. So if we run it, it's going to be, it used to be 1, 2, 3, and now it becomes 292. Makes sense. So, and the usual advice is you kind of, if you want to send information to a function, you should send it via an argument rather than via a global variable. So in kind of exceptional cases, it makes sense to send information via a global variable. So one exception was something like project 1, where you could do it via parameters. It would just be annoying because you would have to send so much information every time. Another situation is like with the login example or with the pseudo-random numbers example, where it's kind of just you have to kind of keep track of what was the value before, and you can kind of do it with parameters as well. It's just that you would have to return the seed every time. All right. Cool. Other questions? We allowed a reference sheet on the midterm. No. What do you think about how much would a complete beginner would be able to score in the midterm? Just a guess. There's like always a very wide range in terms of how everyone performs, including kind of beginners and including experienced people. There are complete beginners who, find that kind of coding is actually what they wanted to do all their life. They just didn't know, and they score like hundreds. There are people who are experienced who don't score that well because like maybe, well, for various reasons. I would say that it's probably the case that, like, of course, like, having previous experience is like better than not having previous experience, like all things being equal. I would say there are studies. So we haven't ever done a study specifically in the ENGSci. What is the effect of having previous experience? There are studies done kind of at other universities, and the evidence is mixed. So sometimes you see that the average for complete beginners is not actually different from the average for people who are not complete beginners. Sometimes you see differences of like 5-10 points between people with experience, people without experience. So like if you gone to my head, what would I guess? I would guess that the average for people with experience is like high 70s. The average for people without experience is like mid 70s is what I would guess. I don't know. I just don't. And some studies say that there's no difference. I find it hard to believe, but maybe it's true. I don't know. Yeah, have a nice day. If we interpret the question wrong and write a code according to the wrong interpretation, but the code is right, do we automatically get a 0? So the answer is like not automatically. I would say it depends on what the misinterpretation is, right? So if you interpret it wrong kind of slightly, then we don't even know that you misinterpreted it. Like we just think that like the code is slightly off. In general, kind of here's what I would say. Like the questions on the midterm, like I said, I think already during the session, are like a contract, right? So if you keep to the contract, so if you answer according to what the words say, doesn't matter what I meant. If you answer according to what the words on the page say, and it's correct, then you get full points, even if your interpretation is different from my interpretation. Now, some of the time, it's like a genuine misinterpretation where you just kind of answer a different question than what the page is asking. And in that kind of case, we look at the specifics. Usually the way we mark it is we just ignore issues of misinterpretation. And it's like, if you basically answer the question, then okay, like maybe you lose some points, but like not a lot. If you basically didn't answer the question, then you probably don't get a lot of points. One reason this issue sometimes comes up is, and I think kind of that's when students kind of come back to me, is if they misinterpreted the question to be like a much easier question than what the question actually is. And then they choose to answer like the much easier question, well, not choose, but like if it's a genuine misinterpretation. To be honest, sometimes people just like pretend they misinterpreted the question because they want to ask, they want to answer the easier question. In those cases, it's kind of kind of case by case, but it's better not to misinterpret the question so that it doesn't come up. Hope that answers this question. Yeah. Yeah, I'm sorry it's broken. I'm a little bit behind. I'll try to and I was kind of like not working very hard on it and kind of catching up on other stuff because I knew that you had like praxis due, but I'll really do my best to do it as soon as possible now. So is praxis was due yesterday, is that right? Yeah, no, I understand. I'm saying kind of for you. Yeah. Wow, but that's like after the midterm, so that doesn't matter. Yeah. Okay. Yeah. I was just like assuming that people were busy with that anyway. But yeah, like I know that I'm late. I'll try to fix it as soon as possible. I don't really count the week, so everything up to the end of Monday. So Monday tomorrow. Yeah. So actually, so let me see if anyone else has other questions, and then I'll answer yours. It's just kind of yeah. Yeah. So Rima, do you want to ask?
I noticed that a type of question that keeps coming up is like when we want to print something and we want to print it on different lines, and let's say like it's the elements of a list, and usually we can use a for loop, but I was wondering also if we use the \n method, it's going to be like way longer, but that should work too, right?
So I think so like it's very rare actually that I don't think like ever on the midterm there was a question where it says like print stuff on different lines. But I think what you're asking is kind of like something like this. So like print the numbers 1 to 10 all on different lines. Something like this, and then you might answer it like this, or you might say something like the answer is initially empty, and then you like keep adding stuff and like this. So eventually, and then you print the answer. So I'll just print like what the string is as well. So if you run this, You just build up a string that's like 1/n, 2/n is tone, then you print it. Like anything that you do where you do what the question asks you to do is fine. It doesn't matter what method you use. Sometimes it's rare that you would see it in the midterm, but sometimes you see kind of questions which specify how you must do something. And then, of course, to the extent that the question specifies how you must do something, then you must follow what the question says.
Okay.
All right. Anyone? So I'll answer your question from the in-person room, but I want to make sure that I got kind of everyone else's questions. If there are any questions from online, anyone? And Rima, could you put your hand down, please, so that because like right now it's like you're like maybe you do have another question actually, but yeah.
I actually put it down. I don't know if it's my screen lagging.
Yeah, it's now that. Yeah, thank you. Yeah, so anyone else? Okay, so the login example is actually quite similar to. So the login example is actually quite similar to the random number example, right? So the basic idea of it is that we want to count how many incorrect logins there are, and if there are 3, then we return something different than if there are not 3, right? So let me write kind of something extremely basic that's like this, right? So it's going to be like login, and I'll have a global count, and initially it's going to be 0. And here count is global. And every time I try to log in, and then here I say if count is greater than 3, then I return false. And else I return true. So in fact, that means that I can just say return count is smaller or equal than 3. Right, so then what I can do is I can print login at first, and then print login again, print login again, print login again. So I'll comment all of that out. And now if I run this, it's going to be true, 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 false. So the reason is I call login the first time. It makes count be 1. So count was 0, and now count is 1. And then I'm returning, is 1 smaller or equal than 3? Well, yes, so I return true. Then the second time I call login, it makes count be 2, and again, it returns true. Next time I call login, it makes count be 3, and then it returns true. Now it makes count be 4, and now count is not smaller or equal than 3, so it will return false. Right? So that's kind of the basic example. So now the difference between this and what we had done in lecture is that here I just automatically, you try to log in more than 3 times, it just returns false. Yeah. So that's kind of almost a separate thing, right? So with the usernames, so we had whatever. So we had usernames and we had passwords. And then we wanted to know whether the password that we have matches the username. So the way we had done it is we said, okay, so we know that the user is Alex, and we want to look up the corresponding password. So the corresponding password to Alice is at passwords at 0. Oh, hi. Yeah. Yeah, so that's a coincidence. So usually people say like Alice and Bob just because they start with A and B, and then like Charlie starts with C. Yeah, I did not know your name is Alice. So, is your password 123 by any chance? So yeah, so we know that Alice's password is at location 0. So how do we get location 0? Well, we can do usernames index user. So that would be 0 if user is Alice, because dot index gives you the location of the first occurrence of this. So this would be 0. So that means that passwords at usernames index user, that is going to be 1, 2, 3. So then we want to ask, is passwords, so is 1, 2, 3 the same as passwords at username.index of user? And if it is, then the password matches. If it's not, that means the password did not match. Does that make sense? Yeah, so that's kind of the basic elements that we just combine. Yeah. 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 So that didn't print anything. We could do something like if this, then we say like, so something like this. And it depends on the situation. So like in the actual login function, what we did is like if it matched, then we reset the counter and we returned true because of the successful login. Otherwise, we returned false. So I would say there's a question in the chat about grading. So I would say, like, in general, the grading schemes are posted on the course website. So you can just look at those, and that should give you a very good idea of how we grade. Like, there are sometimes like small exceptions that are not covered by the grading scheme, but in general it's there. So like the one thing people always ask is, oh, what if I had a completely different idea that doesn't match what the market scheme is? And like sometimes it happens, and in those cases, like it's not very frequent actually. We try to make the market scheme such that it covers like almost everything. And the way we do it is we first look at people's solutions, and then based on that, we make the market schemes. They'll make it ahead of time. But inevitably, sometimes you come up with something that's not covered by the market scheme. And in that case, we kind of look at it case by case. For 2015, question 3. So if the marking scheme is not posted, I do not have it. It's like it was a long time ago. So you just want the answer, I guess.
Yeah, it's the question like we're gonna cover on Monday. I just want to make sure like I understand the concept.
I mean, you can just run those and see what the answers are.
Yeah, true. I'll do that.
the 8 sheet, so, like, honestly, so in recent years, was there, yeah, so, yeah, so I guess like so like the thing is like, so this stuff we haven't covered this year. So this stuff we haven't covered yet. So this stuff, I suppose I could give this out if it helps. I don't think it would help, to be honest, but sure, like if people ask, okay, I'll include that in the midterm. Like everything else is just, oh, I guess there was like, yeah, so there was this, yeah, I mean, yeah, so this we so this one we kind of covered, but not really. So yeah, like whatever we covered, which is gonna be like basically just this stuff, we can include. I don't think it would help, to be honest.
But I want to make sure, like, outside of if they run or not, if they are like really correctly, like the whole index and that stuff.
Okay.
So,
Sorry. So what's the question?
yeah, like if I'm putting the index right, if it's correct to write them like that, so I should be writing them in a different way.
You mean like this stuff?
No, that one, no, like this one, will it be there?
So are you asking if this is correct?
No, like, well, I know it's correct because I already checked it,
Yeah.
but like, if, for example, for the index that we have on Python, like this is correct, and everything, like to write it, or if it's like,
Sorry, I'm not sure what the question is. Like if the code is correct, then it's correct.
no, like when you write it, like it's different when you write it on computer than here. And I suppose that it will have
In what way?
like, for example, when we do it on the code, we have to put these spaces. Like here, so I don't know.
No, I mean, like you did put spaces.
It's kind of this to. I can put this.
I mean, as long as it's clear, it's fine. Right.
I
So
can put like comments like.
yeah, whatever you want.
Like these.
If you want. Yeah. Yeah, I mean, like the answer is like, you know, like you don't have to have those lines, right? So, like as long as it's plausible that you understand what's going on, it's fine. Like what we want to do is we want to chat, like, do you do like, are you doing something that makes sense then?
I think someone will.
Say again?
I think someone is waiting.
I think so. Rima, do you have no? So this is actually from before. Don't think anyone has their hand up currently. Right. If there's no other questions, so I think the next session is like 3:15. So I'll take like a little bit of a break from the football and answer questions, and then I'll be back at 3:15. All right, thanks. Okay. Okay. Yeah, so return it can only be inside the function, right? So here you're not, so this is not inside login, right? Because this needs to be that. Well, yeah. So
If it's not a function, return doesn't make sense. Return means like that's the value of the function. If you're not inside the function, it doesn't mean anything.
Okay. Are you guys staying for the 3:15 session? Okay. Yeah. Okay. So can you make sure that nobody takes my computer? Yeah. Okay. All right. I'll be back.
I'm gonna go in front of it. Hello. How are you? I haven't done anything for coding since yesterday. What's your name? No, and. He called you. He called you Andrew.
Yes.
Andrea.
Andrea, yes.
Nick.
Do you know Candy well? She's the only person I never knew more from.
Ah, I think she said Karen. And then all the. Actually, right. Silence for them. Are you okay? Is there? Do they have sockets here or not?
Yeah, they are like right there. And like, I don't know who's in my house.
That's it. Just that.
Yeah.
No, there's here as well.
Really?
Yeah.
Yeah.
I don't even. Wait, what's your name? I don't.
Sudi.
Sorry,
Sudi.
Sudi?
Yeah.
With a D or an R?
It's ZURI.
Like a zip. Zed. Sudi. Nice to meet you. I'm John.
Like that girl from Jessie. Did you guys watch Jessie? Jessie. Yeah. The show Jessie, did you guys watch that as a kid? You did? There's a girl named Zuri. Yeah, I know.
Do we know if this session will be like asking questions or like Vic is gonna be like,
No, the last one last asking questions, I think you're like really, really quick recap of everything.
today?
That's good.
That's a quick recap of everything today, now.
I don't know.
That's great. I need it. Because you know what? I've been going to lectures, I've been studying, and I still don't know how to do it.
I've been doing past years, it went from 53 to 58. I probably should stop. I think lower.
That's really good though, it's not like you're.
If I even get like
learning.
40% in this, if I even like get 40%, I'll be happy.
No, I won't.
Honestly,
I
you'll
won't.
be your Bob.
No, I don't know, but then that means like my past tests will hopefully like be better, like the future ones, hopefully like 51. Or what do we need, 55? Yeah.
To stay in age.
Oh. Hello.
Still live there. Okay. Yeah, hi. So what I'm gonna try to do here is I'm gonna try to kind of get, well, and everyone here is probably like maybe in different places. I'm gonna try to get you up to speed in terms of kind of the basics, and I'm gonna, as much as possible, start from the beginning. So I'm gonna frame it as just kind of just the first questions from the midterm. And I'm gonna try to kind of say about anything, kind of what's the underlying idea there in the first couple of questions on the midterm. I obviously I don't know where each of you are, so feel free to stop me, ask for more of an explanation if I skip something. So, okay. So this is predicting what's going to happen. So what we have here is we have, so that's kind of just incorrect code.
Professor,
So-
we don't see your screen.
Oh, I see. Thank you. So what's happening here is we have a function. So the idea that's being tested here is that the way you communicate with a function is you send it values via parameters. So what that means is that things look like this. So when you use the function, it's add ends and then 3, 5. So what happens is the 3 gets sent to the X, the 5 gets sent to the Y. So in this case, the function also returns a value. So here it returns X plus Y. I can use this. I can say something like Z is equal to add ends 3, 5, and then I can print the Z. So what's happening here is the 3 gets sent to X, the 5 gets sent to Y, and then the result is X plus Y. So that means that 3 plus 5 here, so that's on the right-hand side, then gets stored in Z. Yes. Yeah. Okay. So so the way to think about it is this is like in math, you would say add ends xy is equal to X plus Y. So the kind of equal X plus Y is the same as the Python return X plus Y. So that's what it means. It doesn't have directly to do with printing. Print means print something on the screen, right? The return, so the return, you should think about it like you think about this equal, right? So that's what the function computes. It's not what's printed directly. It's just that happened. That's being computed. So is that helping? Cool. So, okay. So then the way to think about it, or at least the basic thing that happens, is whatever you return, that's the value here. And that's what, if you say Z equals, then that gets put in Z. And then in this case, we decided to print Z. You could also directly say print add ends 3, 5, right? So this and this are the same, right? And the reason is here, you take this value, add ends 3, 5, so you take the 8, you put in the Z, and then you print the Z, so that prints 8. Or you could just say directly, like, get me the 8. So this part is the 8, and then that's what gets printed. Make sense? So here, what you guys know is you say add ends, but you don't say what to add. That makes no sense. So in the same way that, like, if you think about just the math, x squared is like x times x, right? And then you just say, like, okay, so I'll define the square. And then that's how I define the square. So this makes sense. But saying x is equal to 3 and then square, that makes no sense at all. That's like in math, you're saying square, but you don't say what to square. Right? So it just, so, and it is a syntax error, in fact. So that's like not following the rules of how Python works. It also is not following, so kind of this is like the analogy is like you're saying square, but you're not saying square of what. It doesn't even make sense. So that's this. So here we have, okay, so loopy L. So this is, so like, to be honest, I don't like this question, but this is again an error. So this is just that when you're saying for item in L, it has to be that there is a column, right? So there's, like, again, kind of, it's like just not following the rules not to have a column. So to repeat. So what this is, so I'll just copy this. So this has to have a column, and this has to have a column, this has to have a column. So now this makes sense despite what VS Code thinks. So oh, this is like Python 2, but like what's man? So there's a difference between Python 2, which was like what happened in 2010, and Python 3. So in Python 3, we say print item like this. In Python 2, it was different. So what happens here is we just say, okay, so we send my list to loopy. So that means that L here is going to be 1, 2, 3. And then here we're saying for item in L. So that means that first item will be 1, and then it's going to be 2, and then it's going to be 3. So to remind you, if I have a list, and it's a little bit unfortunate that it's 1, 2, 3, so I'll do like A, B, C, that there's 2 ways to go through the list. So one way to go through the list is to say for E in L. And then here, let's say you're printing E. So this will just print A, and then B, and then C. The other way is to say for I in range length of L. And then I do print L at I. So this is the same, right? So what happens here is just first element of L, so A, and then E becomes B, and then E becomes C. So you print A, then B, then C. Here, you're saying for I in range. So that recalls what we've done in the very beginning with for, so where we said like for I in range 10, for example, we just print I or something. So this would print 0, 1, 2, 3, and so on up to 9. Right, so that's what for I in range does, is I is by default 0, then 1, then 2, and then everything up to but not including 9. So this would be 0, 1, up to 9. So here we're using the same thing. So we're saying I in range length of L. So length of L is 3 because there's 3 elements in L. So I is going to be 0, 1, 2. So that's useful because 0, 1, 2 are exactly the indices inside L, right? So A is L at 0, and B is L at 1, and C is L at 2. Does that make sense? So the trick here is it's always the case that if we just want to say like for I in range length of L, well, that will give you all the indices, all the locations inside the list L. Right? So that means that we'll print L at 0, L at 1, L at 2, and so on up to the last element of L. So just like here, so just that this one, if you don't need to know the locations while you're operating on the elements of the list, this is just easier. Sometimes you do need to know the locations. So an example where you might need to know the locations is, I want to ask, for example, is the list L sorted? Right? So the idea would be that something like this is sorted. And something like this, so like 5, and then whatever, 2, and then 20 is not sorted. Right? And one way to check whether the list is sorted or not is to say, well, like, is this pair of elements sorted? And then is this pair of elements sorted? Is this, so it's like, is each of the neighbors larger or equal to the last neighbor? And if it is, then it's sorted. If you find that you have this kind of thing where the neighbors are not in the correct order, well, the whole list is not in the correct order. Right? So in order to check, like, are there neighbors that are in order or out of order? Well, you can't just do something like this. So you can't just do for E and L, because inside here, I just know what E is. I know the current element, but there's no way for me to access the element from before. So on the other hand, yeah, so that's good. So I could do something like this, right? So I can say for I in range, in this case, I'm saying length of L minus 1 for a reason I'll explain in a second. And here I'm saying if the current neighbor is greater than the neighbor to the right? So for example, if I is 0, we're comparing L at 0 to L at 1. And we're saying if this one is greater than this one, so here it's not, but here it is, then that means that the whole list is not sorted. Yes.
Different the minus one means from the beginning to the end, but how do you start at not the beginning, like in that?
Yeah, well, so so here so what you could, so I think you're asking like if you start with 1, so you can do it like this. Yeah. Yeah, well, so it's not before the length, it's more like if you remember, it's kind of like you can specify like starting at 1, ending just before 5, and then in steps of, for example, 1, or in steps of 2. So it's like begin and then the step. So here, the reason we said length of L minus 1 is that we are saying like compare 0 and 1, and then compare 1 and 2, and then compare 1 and 3, and then compare 3 and 4. But there's no comparing 4 and 5 because there's no 5. So for that reason, we want the last comparison to be between this guy and the neighbor to the right. And this guy is at location length of L minus 2, because the last location is length of L minus 1. So the second to last is length of L minus 2. And here we're saying go up to, but not including length of L minus 1. Yeah.
It's like using length of L like 5, right?
Well, it depends on what L is. For this L, it's 5. Yeah. Yeah. So the number of elements. So oh, there is like stuff in the chat. So there's no such thing as local unbound error. So the error is between. So I think what you're asking about. So I'll answer questions in the chat, and then we'll get to the narrative here. So the two kinds of issues that arise between. Like actually, Kevin, sorry. So can you ask me this at the end of the session, because this is kind of advanced and I want to keep it kind of simple for now. Brackets around the item. No, you do not, if I'm understanding you correctly. So this is completely fine. So the brackets here are because you're saying I is 0, 1, 2, and then this is like L at 0, so the 0th element or the first element. So that's why you have the square brackets. If that's should be able to sort lists. No, we have not done sorting algorithms. We have mentioned that you can do like sorted of L, I believe. All right. Yeah, Aref, do you want to ask a question?
Yes, I have a question. So when you say range of L, what is the range of of length L? Is it the number of elements minus 1, or is it the number of elements?
So the way to think about it is length of L is the number of elements. Now, when I say something like for I in range 10, that means 0, 1 up to 9. Right? So if you start from 0 and go up to, but not including 10, then you have 10 elements, well, not elements, 10 indices, starting at 0, ending at 9, because you start at 0, it's 10, right? So when you're saying for I in range length of L, I goes from 0 up to length of L minus 1. So there are length of L i's because you start from 0. Does that make sense to everyone?
Yes.
So that's like that. And then here it's a little bit different because you are just going to the second to last, right? So the last index is going to be 3. And that's what you want because you want to compare 3 and 4. So 3 and 3 plus 1. But you don't need to compare the last index with whatever comes next because nothing comes next. So that's why the minus 1 over here.
Okay.
Yeah. So, okay. So another thing, so while we're here, so another very useful thing to know about is, so this is called, kind of the technical language for that is not really important, but this is called control flow. So what's going on here? So I'm saying for I in range length of L minus 1, so I'm going through the list, sorry. So I'm going through the list. Sorry, I lost my list. Yeah, so I'm going through the list. So first I is 0. So here, inside here, I'm saying I is 0. Is L at 0 greater than L at 1? And then if it is, then I get to this line. If it's not, I just go to the next iteration, right? So this just doesn't run. The thing to know about, so the thing to know about return is that once you get to the return, you're done, right? So once you get to, so if you ever get to return false, the function just returns false. And that is the structure of the problem that kind of fits with this, because what we're saying is if you ever find one example where L at I is greater than L at I plus 1, like here, like 5 and then 2, you know that the answer is that the list is not sorted. You don't need to look any further. So for that reason, you go from here, that's it. You're done if you ever get to return false. So one thing that people often ask is, well, can you do like else return false? And return true in this case, I guess. And the answer is definitely not. And the reason the answer is not is because if you do it like this, then right away for I equals 0, either you return true or you return false. But that's not what you want, because if you say, oh, 5 is smaller than 6, you don't know the answer for whether the entire list is sorted. It's just that for this example, it's fine. You still need to check this, and then you need to check this, and so on. Right. So the structure is return false right away if you see a situation where L at I is greater than L at I plus 1, because you know that the answer is definitely false. You don't need to look any further. And then after the loop has run over here, so after you've finished, if you've never returned false, then you'll get to line 29 and you'll return true. So the structure here is you're looking for kind of a counter example. If you found it, just return false right away. You return true if you never returned false while the loop was running. Yes.
Why isn't it like greater than I?
Well, so that's more kind of like about the definition of problems, right? So here I kind of just said that this would be considered sorted. So if there is repetition, then I count it as sorted. In this case, if it were L at I greater or equal than L at I plus 1, then when I compare this 10 and this 10, I'll return false. And it's a matter of definition, whether you want to count it as sorted or not. In this case, I decided that counts as sorted. So that means that I only return false if they're out of order. If they're equal, then it's fine. Makes sense? Yeah, a ref. There's actually 2 refs. That's probably the same person. Yeah, a ref, do you have a question or is it?
No, I don't. I'm good.
Okay. Cool. Does the opposite also work? No, it does not. So that's a good question though. So here's kind of the suggestion. And I guess you flip those. So this doesn't work. So the reason this doesn't work is, or at least works differently, is that here you're saying right away, if L at 0 and L at 1 are in the right order, you're just saying return true, and the function will just return true. But just because L at 0 and L at 1 are in the right order doesn't mean that everything is sorted. So you can't return true right away if that's the situation. But that's a good example to think about. Is that clear? Okay, cool. Is L at I plus 1 going to go beyond? Well, so no, that's why we said range length of L minus 1. Right, so here the last I is going to be length of L minus 2, and then that plus 1 is length of L minus 1, so that's still in the range. All right. Cool. All right. So let's do the next one. So so here we have sum to n, and we say total is n times n plus 1 over 2. And here we print total. So the problem here is that total is a local variable. So the way to think about it, or at least kind of the way I think about those, maybe it's different for different people, is local variables. And local variables would be those things inside functions that are not explicitly declared as global. So everything is local by default. Local variables are like scratch space. They go away after the function has finished running. So you cannot access total after the function has finished running. The way to communicate with functions in general is like, that's what we said before, right? So we return x squared. So the way we communicate information to the function is by sending this argument to the function. So by copying the 5 to x. The way we generally communicate information out of the function is by returning something. So the x times x is just going to be whatever is the value here. Right? Anything else is suspect. Now, it's true that in some cases, you can both communicate information to the function and communicate information out of the function via a global variable. So this would mean something like this. So I could say something like global current square. So say current square is global, and then say current square is x times x. So then if I say square 5, what would happen is the 5 gets sent to x, and then this I don't even need anymore. Current square gets set to x times x. So 5 gets set to x, and then the global variable current square gets set to x squared. Does that make sense? So then I can print current square, and that would print 25. So what I had to do in order to accomplish this was to say inside this function, whatever I'm setting, that's going to be a global variable. And I'm going to set the global variable, well, do whatever I want, in this case, x times x. And then I run this function. So instead of doing kind of the usual math thing where it returns right away, I'm saying the job of this function is to set the value of current square to, in this case, 25. And then I can check that, yes, indeed, the value of current square is whatever, 25. All right. So that's not how you should write code in general. There were exceptions. So sometimes, like in the login example from class, like in the pseudo-random number generation from class, you want for the function to set the global variable to something because you want to retain information between different calls to the function. So I think the most intuitive way to think about this is the login example, right? So So the login function, if you successfully log in, it returns true. If you don't successfully log in, it returns false. But there is information that you want to retain about previous calls. Specifically, you want to know how many failed calls there were to this function. So for that reason, you store that information about how many failed calls there were in a global variable. Right. In general, though, it's not the situation. In general, you just communicate information in via X and you return X squared. So getting back to this, well, what's the problem here? Well, like that's just a trivial thing. So tool is a local variable, cannot access it outside of the function. Make sense? All right. What do we have here? So here, again, same thing. So value is not global in here. So that means that when you say value is equal to 4, and it couldn't be because you cannot set value to be global because it's a parameter. So when you say value equals 42, again, scratch work, it's gonna go away. Now, if you say inside the function value is 42, print value, well, that's going to print 42. So what's going to happen here is outside the function, value is 1. So this is 1. So then you say printer value. So 1 gets sent here. 1, then temporarily as scratch work, set value to 42. 42 gets printed. But that does not change value outside the function. So that is still 1. So the rule is unless the function is, the variable, sorry, is explicitly global inside the function, that means it's local. That means you set it to something new that only matters inside the function. It doesn't matter outside the function. So one reason this is confusing, and this I would not say is a basic question anyway, but one reason this is confusing is that you have value that's outside the function and you have value that's inside the function, and those have the same name, but they're different variables. So you have the global value and you have the local value, right? So this value, the parameter is a local variable, only exists inside the function. It so happens that initially, the value here is the same as the value here because you send it as a parameter. So that's an extremely usual thing, a bit unfortunate, but like there is a reason why that is so. So this is the basic situation, right? You're saying something like, whatever, square 5. So here you could say x is equal to 5. And then so I'll do something silly. So it's something like this. So here I'm saying square of x. And naturally, like this guy and this guy would have the same name because they represent, it's a silly example because I'm messing it up on purpose. But naturally, like you want to square x, well, it's going to be named x here and it's going to be named x here because, well, they both store the same kind of thing, the thing that I want to square. So naturally, they would have the same name. But there are different values, right? So the x outside of any function is the global x. The x that's local here is the local x. So saying x equals 50 here matters for the local x, but doesn't change the global x. So you print x here, and that is 5. Right, so x is 50 only inside the function. Yeah.
So for the square x, that would turn like
No, 25. So here I'm saying res is equal x times x. So that means that res would be 25. and then X is 50, but I don't care. And then I'm saying return res, so that means res is 25, right?
So when I write like square of X, is that X the global variable X?
Yes, well, so outside of any function, I say square of X. Well, like it's this X, which is outside of any function. So the thing that kind of helps me think about it is saying square of X is the same as saying square of 5. Either way, what you're doing is you're saying X is equal to 5, the local X here. Right? It doesn't, so it's so kind of the thing that's a little bit misleading here, but like it has to be this way because the local X and the global X initially store the same value. So naturally they would be named the same thing. But really what's happening is you're copying the value here to the value here. It just happens that this is also X, but it would be the same if you said square of 5. Does that make sense? And then like if you say square root of 5, like naturally you wouldn't think that like the value of 5 would change just because you're saying x is equal to 50 here. So value does have a value at the beginning. Value is 1 from over here. All right. So, okay. It would be the output. So the output is 142. Sorry. So 1, then 142 because this is 1 and this is 42, and then 1. Value is a global variable. So value equals 1 here is defined outside of the function.
So how do we like write that? Like just 1 and then only 1.
Yeah. Yeah, like I guess like 1, then 1, then 42, then 1 again, all different lines. Yeah.
So for integer value, it returns like 2 bytes.
It prints 2 values. Yeah, well, because you have like print value here. So this would print, for example, 1, and this would print 42. When we call variable in printer, well, I mean, you couldn't because value is a parameter, right? So when you're, yeah, it's saved on YouTube. Yeah, so value is a parameter, right? So it's like the x here. Right, so it's not global. It's kind of you're sending, for example, this 5 to this x. Does that make sense? All right. Okay. So here we have the function printer. So the job of the function printer is to print hello. And then we have stuff that's outside of printer. So when you're running this code, what happens? So here, this is just the definition of a function printer. By itself, it doesn't print anything. You have to call it in order to print hello. So what happens here is first hi gets printed, and then hello gets printed, and then hello gets printed again. So the trick here is that this doesn't print anything by itself, right? So this prints hello when you use the function printer. But just saying this is the definition of the function doesn't do anything. Say again?
If you said return instead of.
Yeah, because if you say return, it's not going to print anything at all. So you could So if you say like return hello, like you can say it. But now you run it and you need to save it. And it just prints hi, right? So the reason it just prints hi is because this prints hi, but this has the value hello, but there's no instruction to print it. So you can print hello by saying print printer. So then the value of this is hello, and then you're telling Python print the hello. Right, so this would be hi hello, and then this doesn't print anything because there's no instruction to print anything. You cannot print without the brackets. Yeah, so like it's just that the 20 turn midterm is in a different version of Python where you could do that. So this is hi hello. Yes.
You change the return hello into print hello, and then you print return.
Yeah. Well, so what's going to happen is print is a function that has a job. Its job is to output hello. It doesn't return anything. So and here you're not saying return anything. So this function doesn't return anything for sure. So by default, if a function doesn't return anything, it returns none. So the default return value. So if you say print printer and printer doesn't return anything, then this will print none. So what will happen is, so this of course prints hi, and then this gets called. So you get to this line that prints hello, and then the value of this is none. So then what you'll get is first hello, and then none because of this print. And then this one prints hello again. Right, so this is going to be hi, and then hello. Yes, that's right. And then none, and then hello. Right. Okay. This one sometimes confuses people for like no good reason. So this is like what you think it is if you don't if you don't confuse yourself. So put 11 in var A. So var A is now 11. Put var A in var B. So var B is now 11 as well. Put 42 in var A. Well, var A is 42. Var B is still 11. Right. So saying var A is something new does not affect var B. Make sense? So I guess kind of like conceptually, the way to think about it is this is an instruction saying whatever's in the right-hand side, put in the left-hand side. So put 11 in var A, put 11 in var B, put 42 in var A. So it's not like math where like you're saying var B equals var A, they're like the same thing forever. There is a thing with aliasing, but it doesn't arise here. That only arises with stuff like lists, and that we'll just start talking about on Friday and talk more about on Monday, but it doesn't come up here. Like a long midterm. So what's happening here? So we have kind of one way to think about it is like it's named Findo, and we're like usually not trying to mislead you. So you can kind of try to figure out, okay, like what is it supposed to do? And the answer is it's supposed to find the location of O inside search string. Right, so this means that if you have a string like this, well, then the location of the O is 3. Okay. And the way it's trying to do it, so let's say that this is search string. So the way it's trying to do it, what was the name? Index. So that would actually be a better way. But anyway, so the way it's trying to do it is, so I'll explain while loops in a second again. So just, yeah, so index. Return index. So what we're doing here is like this. We're saying initially index is going to be 0. And then we are going to keep increasing index. So this is the index plus equals 1. While search string at index is not what we're looking for. Right. So what we're going to do is we're going to say, is this condition true? So this condition would be true if index is smaller than the length. So we haven't gone out of the string yet. And also search string at index is not O. So if we haven't found the O yet, so if search string at index is not O, so like at search string at 0 is A, not O, not O, not O. So if we haven't found it, and also there is space to look for the O still, then we increase the index. So the trick here is that when we've gotten to this point, well, why would we gotten to this point? Well, it's because this has become false. So initially this is true because index is small. Initially index is 0, so it's smaller, and we're still like, there's still something to look for. And also initially search string at index is not O. So here the trick is, and it's similar to before when we return true after not returning false. If we're at this point, it must mean that this has become false. Why would it become false? Well, hopefully because search string at index has become O. So if search string at index has become O, so index was 0, then 1, then 2, and so on. And then at some point, this has become false. Then you say, oh, we're done. Just skip to line 20. Make sense? So here the question, I guess, was just like the location of the O here is 3. And then the location of O here is 1. And then this one doesn't have O. And this will also become false if index becomes length of search string. So that means that there's no point in looking at search string index because that's not the valid location anymore, because that's like the thing that's after the last character. So if you haven't found an O, then what you'll return is just the length of the search string. So in this case, 6.
So I have a question.
Yeah.
Is the slash a typo in this exam, or does it mean something?
The slash is not a typo. So it's just that we haven't done it in lecture this year. But if you have a very long line, then this is a way to continue the line. Is like you do slash and then you can continue on another line.
Okay, I see. I have another question.
Yeah. Go ahead.
Oh, wait, never mind. It was answered. Sorry.
Yeah. Yeah.
You said that it returned for the last word 6.
That's right.
Why would it return 6, not 5?
Well, because you stop this when index is not smaller than the length of the search string.
Yeah.
The length of the search string is 6. So this is like 0, 1, 2, 3, 4. 5 is still smaller than the length of the search string. So when index is 5, you'll increase index by 1, and then you'll come around again, and then you say, is 6 smaller than 6? No. Okay, go to this line, return 6.
Oh, so when as a function returns
The number of
the
elements.
number as we count, not as I count.
The number of elements rather than
Yeah.
the number of elements rather than the last index. Yeah.
Okay.
Yeah. So the length, like just think about it as the length. The length is not the same as like the location of the last element. It's like how many elements are there.
Okay. Okay, great.
Yeah.
So the slash thing that makes things in the next sentence but still makes sense. Like during the exam, if we are writing.
Oh, I mean, you can, but you could also draw an arrow or something. Yeah. This we haven't done yet. This we haven't done yet. This we have done, but I want to skip. Okay, the X question is kind of silly. Okay, so let's maybe go and do another question, and then we'll take a break. Yeah.
Question again. So for the last element of question 1G, it will return 6, but for the other two will return 3 and 1.
Well, whatever is the location of the O. Yeah. So the location of the O here is 3. And the location of the O here is 1.
Oh.
Yeah. Well, there's no true and false here, right? So we always return. And that's the thing, kind of, if you get a question where it's asking you what's the output, like, look at like, okay, here it returns index. So in this case, index is just because index starts out at 0, it's always some kind of number. So it's not like true and false, it's a number.
Oh, yeah.
Right. Okay, all right. So why don't we do it like this? So like if you have, so I want to take a kind of a short break. If you have requests, please put them in the chat. If you don't have requests, I'll just do a couple more questions, kind of from other midterms. All right. Okay. Yeah. So just give me like break, continue. Sure. Yeah. Yeah. Oh, okay. Yeah. Yeah. Just put whatever you want in the chat. Yeah. So yeah. So we'll be back in like, let's call it like 7 minutes.
Oh, thank you.
Limited supply available to people who need to queue up and haven't had lunch.
Oh, thanks. Oh, this reminds me.
Yeah.
Yeah.
yeah, like I haven't eaten either, so I just took them in case I was like getting really hungry, but at the same time, I don't want to eat all of them because it's probably bad for you. Yeah, in small quantities. I ate like 2, as I decided that that's probably enough.
How was the game?
I lost most of it. It's on YouTube if you like. So I'm actually like on the website now, like paying up whatever I said I would. So yeah, I just put it in the chat, please, so that they don't forget. Yeah, All right.
Could you please cover flexing as well?
Yeah. Yeah. So. Yeah, so it's all recorded. This is me scoring. Okay, that's not great. Okay, anyway. So oh yeah. Yeah, there you are. So okay. So okay, all right. Yes, I just like during the break I just paid up. So okay, so I'll practice more for next time. Where's the chat? Okay, so let me kind of do kind of quick things first. So what's the average of past year's midterms? So like it varies between low 70s and high 70s, basically, is the usual range. Now, I would say, and this applies to this class as well as most other classes in engineering science, at the end of the day, like mostly the averages in the the final averages in the courses are going to range between like 74 and 79, basically, is the usual thing. There can be exceptions, but they're rare. So that means that like the numerical outcome, like it's of limited utility in terms of predicting your grade, because at the end of the day, like if the performance of the class is very low, like it could be that the instructor decides that, well, that's because the class just didn't do very well and doesn't deserve high marks. But most of the time, the instructor kind of looks at the test and says, well, like the reason people didn't do well is maybe it was too difficult, so I'll just adjust the grades, and that happens quite a lot. So like thinking about the numbers, I think, is like not that useful. To some extent, it's certainly like sometimes, in fact, you know, like it happened, like in my experience. So like there were classes like where the instructor just said, well, like, no, like it wasn't that, like, yes, the performance is lower than usual, but well, it's just that because like either I didn't teach, it wasn't me, but like either I didn't teach well enough or the students didn't learn well enough, but either way, the outcome was the outcome. I'm not just adjusting it. That also does happen, but a lot of the time it gets adjusted. So yeah. All right, so let's see. Okay, so I'll just look for like the quick ones, and then I'll answer the quick ones first, and then we'll move on to the not so quick ones, I guess. So break, continue, not quick. Question 4, no idea. Integer division with negative numbers, don't worry about it. So like basically the only thing that we've done in terms of integer division plus modulo is we said that the basic idea is something like this. So I'll do it with concrete numbers first. So 9/2 is like basically 4. So that means that if you back multiply, you'll get almost 9, but not always 9, right? Because 9/2, it's like integer division, that's 4, that's not 4.5. So this is like almost 9, but not quite 9. So 9 mod 2 is the thing that you need to add in order to get back to 9. That's one way of thinking about it, right? So this is 2 times 4 plus 1, right? So the 1 is the thing that you need to add back in order to get back to exactly 9. And then the question arises, well, like, okay, like what's like -9 mod 2? What's 9 mod -2? And the answer is like, it's not worth worrying about. The only thing that you would know is that, yes, like if you have -9, then that is gonna, so I'm just putting it in parentheses to make sure that it's like -9, then mod 2. Rather than -9 mod 2 as a whole. The only thing is that this is still going to be true. Now, how is it going to be true? Well, Python is going to figure it out, and it's not always necessarily going to be consistent. So in this case, if you do -9 mod 2, that is going to be 1. So if that's going to be 1, then, well, what's -9 divided 2? Well, that's -5. Why? Well, because it's going to work out. There are rules about how it works. Those rules are not actually in the definition of the language. So every particular Python, like, yes, it works according to some rules. We haven't covered what those rules are. It's not worth knowing, in my opinion, because like if you actually know what you want, just do it. Don't rely on like arcane rules for like what is it going to be. And like one thing is that sometimes, but not all the time, this is gonna surprise you. In this case, actually, it worked out. So is it, can I get something that's not negative? Yeah, so here, like, is it -7? Is it -5? Whatever. So yeah, so that's kind of like this. So can I trip it up? Yeah, so in this, so here it just does something, but it really depends on depends on the version. So the only thing to know is this. So I can write it in general. So it's like A is equal to B times A divided by B plus A mod B. Right. And the idea is, well, like, this is like almost A, but not quite. And then A mod B is the thing that you would add in order to make it back to A. Yeah. So it works for everything. All right. Okay. So the difference between floor and int. So int. So first of all, int converts to an integer, floor does not. So int truncates. So int of 3.14 is 3, and int of -3.14 is -3. So int always truncates. So truncates just means take away the fractional part. On the other hand, floor rounds down. Right, so floor and int kind of produce numbers that are equal for positives, but not for negatives. Because floor just always rounds down, so round down from -3.8, that's -4. Truncate -3.8, that's -3. All right. So types of division. So the regular division is just like give me the exact number. So like 5 divided by 2 is 2.5. On the other hand, so 5 divided by 2 is an unfortunate example. So 15 divided by 2 is 7.5. 15 divided by 2, that's integer division. So that works according to those rules. For positives, it's basic. For positive numbers, it's basically divide and then round up. And that's the only thing that's worth knowing about. Yeah. No, so it's that this is just the kind of exact division. So not exact, but like floating point division. So this will give you a fractional result. And then this will give you an integer result. For positives, yes. So for negatives, as you saw, it's more complicated than that. So here, for example, you see that -13 divided by 2 is like not -6.5 to remove the fractional part. It's actually like -7. No, so you don't need to remember the rules. It's just that, so like for positives, it's yes, like it's the same as truncate. That's true. I think about it more as just round down rather than truncate. All right. Okay, not gonna do, so this we've done. Next integer of pi. Yeah. So Q5, should we know integer division? Well, like basically no. Okay, like half the questions are about this. Okay. So before I do all this other stuff, I want to ask kind of primarily, I guess, the people who are here. Do you feel so? basically what I could do is I could also like look at coding bat warm up, and kind of, if you're having trouble with that, try to get you started. Is there anyone who wants that? Okay, I'm glad. Okay, so what we're also going to do, so I'll ask some of the TAs to have kind of small sessions where, you know, kind of maybe if you kind of feel like you and friends are in the same position, you could just go book a TA for like 5 people or maybe fewer, and then kind of you'll tell the TAs exactly what you need, and hopefully they'll help you. So yeah. The time for the lab. So it depends. So some of the TAs are available for the lab kind of. I guess I'll send in some TAs into the lab. Yeah. So like not all of them, but like I'll send some of them, so you can just go to the lab and get help there. Yeah. So there's not going to be. Oh well, actually. I'm taking it back. So there might be a lab actually this week. So I'll need to check. And if there is a lab, you just need to do the lab. So yeah. All right.
About the hours you said about the lab.
Yeah.
About the TAs.
Yeah.
Are you gonna just do something?
Yeah. So once I organize it, it's gonna be posted. Yeah.
Oh.
Yeah. All right. So all right. Break, continue, and so on. So basically the way it works is like this. So basically you have some kind of loop. So for example, the simplest possible thing. So for I in range 10 or something. And then by default, that would just print like 0, 1, 2, and so on. Up to 9. So 2 things that you can do here with break and continue. So you can say, I want to skip an iteration, and you can say, I want to get out of the loop. So for example, you might say, if I is equal to 5, I want to skip the iteration. So what this means is that when I is 0, well, you just don't do anything. If I is not 5, so you don't even get to continue. If I is 5, you get to the continue. So continue means just whatever you are doing over here, it's over. Just go to the next I. So the effect would be that you won't get to print I when I is equal to 5. So that would print everything, but you are skipping over 5. And the reason is when I is equal to 5, you hit the continue. Continue means just go back here for the next I. So break means break out of the loop. So if you do this, then once I gets to be 5, so I is 0, you print 0, I is 1, you print 1, and so on. And then when I is 5, you get to the break. Break means you're done with the loop. So if you have anything here, like you have like whatever end, then end is going to be printed because you go just to whatever happens after the loop once you hit the break. Right? Okay. Sorry, forgot the question. Oh, it's right here. Question 4 in 2022. Yeah. So continue means go to the next. Pass just means nothing, right? So if you do pass, then doesn't matter. Like it doesn't actually do anything, right? Because pass is just like a placeholder. Continue means go to the next iteration. So if continue happens in the middle, then you will skip over whatever happens after the continue. So that's why here you're skipping over the 5. Sorry, speak up, please. So like this just doesn't do anything. It's like if I is not equal to 5, then obviously nothing happens. And then if I is equal to 5, also nothing happens. So like this whole thing just doesn't do anything. It'll just print 0, 1, 2 up to 9, everything. All right. All right, Q4. 2022. Oh, it's this one. Okay, so we stored the matrix as a list of lists. So first of all, what's going on here, right? So we store this matrix as a list whose elements are themselves lists, right? So let me copy this. So what does this mean? So if I say this, so L at 0, what is L at 0? L at 0 is the first element of this list. The first element is 5, 0, 0. And the second element is 0, 0, 1. So then what you can do is you can say, okay, L at 0 is 5, 0, 0. So then L at 0 is the first element of L at 0. So that's the 5. Does that make sense to everyone? And then if I want the 1, for example, what is it? Well, this is L at 1. And the 1 is element number 2 because 0, 1, 2. So L at 1 at 2 is the 1. Right? So in effect, you've done matrices already in 103, right? Yeah. So it's this, it's so it's the same, right? So so the only thing is we start with 0 rather than at 1 when indexing, but it's the same. So if you arrange this and like this one, like it's just prettier, right? It's the same thing. It's just that like instead of doing this like after the comma, I just align those things so that it kind of looks like a matrix, right? So L00 is the 5. So in 103, you would call it like element 1, 1. So this is like 1, 2, and ESC103 would say this is like second row, third column. So 2, 3. Right. So just that we start with 0 instead of 1. So it's like everything is -1. But this is like not because we're using matrices in Python, right? So like all we are doing here is we're using. So all we're doing here is we're using lists. And then because L at 1 is itself a list, then if we want to get to this guy, we're just saying, well, this is element number 2 in LS1, so just do element number 2. All right. Okay. So what we're being asked to do here is we're asked to add 2 of those guys. And so let's make 2 of those guys. Yeah.
Do we know the dimensions? Like,
We don't, so you're supposed to say error if they don't match.
how,
Well, suggest something. Okay, I'll change them a little bit. All right. That is not true. So, okay. So is it like matrix sum or something? Yeah. Yeah, it's interesting. Well, I guess I saw it as well, so it might have been in my subconscious, but like the other possibility is like if I wrote it like last year and I think what should it be named? Like I'm the same person, so I didn't know what the name was going to be, but then I just said, well, like what would I say about it? What would I pick as a name? So yeah. Anyway, so matrix sum. So the instructions are if the dimensions don't match, we should return an error. So how do we check whether the dimensions match? Well, oops. Well, what's the number of rows? The number of rows is the number of elements, right? Because this is one element, so that's one row, and that's another element, so that's another row. So that's length. So I'll write it kind of a little bit more elaborately than this. So the number of rows is this, and then the number of rows 2 is going to be length of M2. And then what about the number of columns? So here, right, so the number of columns is how many entries are there in here, right? Because like the number of entries in the first row, that's the same as the number of columns. Because like the columns go like down from the first down from each of 5 and 0 and 0. Does that make sense? So the way I would write it is I would say just like M1 at 0. So that's the first row of M1. And I'm going to ask, what's the length of that? And similarly, I'll do for num columns too. So now I'll say, okay, if the dimensions don't match, how could they not match? Well, like either the rows don't match or the columns don't match. So if they don't match, the instruction is to, I think, return the string error. So that means return error. And here it's kind of like if I return error already, I don't worry about it. So after the if statement, I'll just continue writing because if I needed to return error, I already returned error. So what I need to do now is so because this is supposed to be the catch-up session, I'm going to do a little bit of diversion into a general technique. So let's say that I want to compute the sum of a list of numbers, yes. So how would I do it? Well, I would say first total is 0. And then I'll just build the answer up. How do I build up the answer? In this case, well, I get each element of the list L, and I add that element into the total. And then at the end, I'll just return the total. So that's a very general technique that you see a lot. You start with the initial answer. So you say, well, initially total is 0. And then you go through whatever it is that you need to go through, and you somehow add into the total. It's not necessarily always going to be plus equals, but like something like this. Yeah.
Oh, isn't there like also a sum?
Yeah, totally. It's just an example. Yeah.
So we can also use.
Yeah. All right. So here, what I'll do is I'll do kind of like result initially is going to be empty. And here, I just need to build up the result. So the result is the sum of M1 and M2. So, okay. So here's how that's going to go. So it's not kind of super easy. Last year, actually, like people saw, well, like you saw kind of an example last week as well in the lab. But what we're doing is we're building it row by row. So here I'm saying kind of for row number 0 and row number 1 and row number 2 and so on, build up the row in the answer. So I'm saying row initially is going to be the empty list. That's the row of the answer that I'm building up. And then for each column, I'll append the sum of the entries to the row. So here's what's happening. I'm starting with result being just the empty list. I want for the result to become, in this case, like 12 to 0 initially, right? So what I want to do is I want row to be this. So I start with res is this and row is this. And then I say, okay, so row, append 12 to it. So append 5 plus 1, 5 plus 7. So that row will become 12. And then append 0 plus 2. So row will become 2. So then append 0 plus 0. So row will become 0. And then once I've built up the row, I'll say append the entire row to result. And then I'll start again. So row is going to be empty again. And then I'll append 0 plus 0. So it'll be 0. And then I'll append this 0 plus 0, this 0. So it'll become 0. And then I'll append this 1 plus this 5. So it'll become 6. And then once I'm done with it, I'll say append this entire row to result. And that's what I want. Now result is the sum. Okay, so that's the process. So now I want the implementation of this process. So I need to build up the first row of the sum, then the second row of the sum, then the third row of the sum, and so on. Make sense? So like that's kind of the overview. So the way I'm accomplishing it is I'm saying row initially, I'll set it to be empty. And then I is 0 initially. And then I'm saying append M100 plus M200. And then append M101 plus M201. Append M102 plus M202. Right? So for I equals 0, what this does is it builds up row number 0. Does that make sense? So I is constant. And then j goes from 0 to 1 to 2, so that I append like the first sum I want, the second sum I want, the third sum I want. And then once I have built up the row, then I just append it to result. So when I equals 0, what the highlighted code does is it builds up the first row and it sticks it into result. Right? And then I becomes 1, and again, builds up the second row, sticks it in the result. If there's a third row, again, we'll just build it up, stick it into result. So in terms of problem solving, right? How do you do it? I would say like not an easy question. And in part, it's kind of made easier by the fact that like you've practiced with tic-tac-toe. Like without that, it would be very difficult. So you just say kind of one thing at a time, right? So result will have to start with something. We'll just start with nothing. And then you say, how do I change result a little bit so that it's closer to the answer? And well, like if you understand how the matrix works, where it's a list of lists, then you say, well, like, you know, got to add the first row first and then the second row and so on. And then the question becomes, okay, how do I do the first row? And the answer is, well, what's the first row? Well, the first row is like, so I'll write it out explicitly. So the first row is like M100 plus M200. And then M101, yeah, that's right. M101 plus M201, and then M102 plus M202. So then you look and say, okay, so this 0 is always 0. Well, because it's row number 0. And here, like, it's like 0, and then 1, and then 2. So gotta have a loop that does something like this. Right? And this is exactly what we do. So we say for J in range number of columns, so how many times should we repeat? Well, as many times as we have entries in the row. Right? And then J, so this is like J is 0, and then this is J is 1, and then this is J is 2. Does that make sense? So I don't know my audience here. So like, if you don't complain, I'm just gonna move on. Yeah.
Go over the row of 10, like the
Yeah. Yeah.
How does it change when that
Right. Well, so row starts off as an empty list every time. Right.
Yeah.
And then we're saying when J is, so row initially is just empty. And then when J is 1, we compute this guy and we append it to row. So row used to be empty and now it becomes this. And then J becomes 1 and we compute this guy and we append it to row. So row used to have 1 element and now it has 2 elements. And then the next time we append this.
And then like when I becomes 1, we just do that anything.
That's right. So this is building up 1 row and then we append the entire row to result. So then result has just 1 row in it at first. Well, at first it has nothing. Then it has 1 row. Then we build up the second row and again. Make sense? All right. Next integer of pi. So to be honest, I think kind of, I don't know that I'm going to do a better job the second time I do it, and it's already recorded. So I'll do it kind of maybe quickly, and then I'll ask people to stop me if something is unclear. So this is for the digits of pi, right? So the basic idea is we have a pi string, right? And that's just str math.pi. Oh, without that, it's not going to work at all. So the idea is that if you say like just like my pi is mat.pi. So my pi is this, but you cannot do like my pi at 0. That makes no sense for a float. On the other hand, if you convert it to a string, so now it's a string, and with a string, you can say what's pi string at 0, and then what's pi string at 1, what's pi string at 2. Make sense? So we have this. So now what we want is we want to get 3 and then 1 and then 4 and so on. Okay. So the way we'll do it is we'll have a global variable that's initially 0. And yeah. And the way, so this is just from lecture, right? So, and the way we'll do it in this case is we'll say, okay, so increment int by 1, and then return pi string at int minus 1. So the first time we'll return pi string at 0 because int becomes 1 and we return pi string at 0, no, 1 minus 1, so 0. Then the second time we do pi string 1. The third time we do pi string 2. Right? Does that make sense to everyone? So we've already kind of done the global thing, so I'm kind of skipping over it. But if you have questions, please ask. So the only thing is pi string had this dot, so the decimal point, and we don't want to display that. So how do we get rid of it? Well, what we can say is, okay, if it happens that end is equal to 2, in which case we'll return the decimal point. Well, we want to advance end by 1 more, right? So I'll just say if end this is equal to 2, increment it once more. So what happens is we return pi string at 0, and then right away pi string at 3 minus 1, so pi string at 2, string at 3, and so on. No, it should be 2. So the only thing is we want to, when end is equal to 2, we don't want to return pi string at 2 minus 1 because that's the decimal point. We want to return 1 right away. So what we do is, like, if we see that end happens to be 2 and we're about to return pi string 2 minus 1, just increase it 1 more so that we return pi string 3 minus 1. Everything else is fine.
So if end equals to 3, do you want to print 1 or do you want to print 4?
If end is equal to 3, we want to print 2. Oh, you mean the digit. So so if end is equal to 3, we want to print 4, which we will. Sorry, 3, actually 3, we want to print 1. And then the next time it's going to become like end and the digits is confusing. So it's that end first it's 0, then it's 1, then it's 2, but it skips to 3 right away, and then it's 4, then it's 5, so it's all fine. Does that make sense? Yeah.
I just have a question. Is there any reason why we need to actually make end global? What if we put end equals 0 inside the function?
So there is, right? Because we want to able to say, like in the main block, so we want to be able to say this, right? So we don't want to specify which digit it is that we want to print. We just want to say, get me the next digit and then the next digit again, then the next digit again.
Okay, I see.
So you could imagine that like we would send the end over here, but that's just not what the question was asking. So
Yeah,
you
okay,
could
I understand.
be like, get me like the fourth digit or whatever. Yeah. And it's the same pattern where in the global variable, we keep track of which digit we already have done and which digit we should do next, or like basically the index of the digit that we should do next.
The digit is equal to the point then completed.
Well, I mean, I want to actually print something. It's not that I want to print nothing, right? So I want to return the next digit. Yeah. Well, yeah, just because the question on the midterm like asked for that, right? It said like print 3, then 1, then 4, and like it didn't say anything about the point. I mean, it depends on when it is that the index is 1, right? So if the index is 1 in the beginning, index will become 2. And then index will become 3 right away, and then you'll print pi string at 2. So maybe like the way to think about it is, okay, like initially index is 1. 0 rather. And this will print first digit. And then this will print the second digit. And then this will print the third digit. Right? And the way it's going to go is index initially is 0, and then over here index is 1, and then here index is 3. Well, like initially when index is 1, so that's over here, right? So when index is 1, next digit, index becomes 2. If index is 2, make it 3. And then return pi string at 3 minus 2. So return the second digit. And now index is 3. We just skipped over it. And then next time index is going to be 4. Yeah. All right. Our Q5 2015. Okay, so this is like not really an introductory thing. So let me defer. I think I answered. Did I say that I'll answer something later? I forgot. But like Q5 is like I also want to defer for later. I imagine Q6, definitely Q6. Oh, this is like 1 point. So yeah, like it was a bonus question. So like the amount of marks does not necessarily kind of correspond to the difficulty of the question. It's more like I was like making the midterm and I thought, well, like, why don't I put in a bonus question? And like, if someone is done with everything else, they can do a bonus question for like a few points. That's the idea. Not always the philosophy that people use. It's just like what I decided that time. And in fact, like so this was like not officially a bonus. It has become a bonus after the fact. I think it wasn't officially a bonus. So like for a question to become a bonus, you just say, well, everyone gets the kind of, so it's like out of whatever the total minus 1 rather than out of the total, and then you can get 100 without getting question 6. But yeah, like that was just like the decision in 2015. Okay, negatives. My lab is on Thursday. What's my lab? Oh, you're okay. Yes. So it's true. So like the lab, if there is a lab, would be more preparation for project 2 rather than for the exam. So just because it is. How do we build up the second row? I think that was like a question, like as I was explaining, hopefully that was explained. How many digits does math? How many digits does math.py give? Like we said, like a flow. So it depends on the system actually, but like about 18. Q6 hard-coded 200 lines. Yeah, like actually, like you're not the only one who hard-coded stuff for Q6. I had not considered the possibility that people would just do that. If I thought about that, I would just say like 12 integers rather than 8 integers. But yeah. Of course, these days, like you can make Copilot do it. Of course, Copilot probably knows a better way as well. Definitely possible to do it in fewer than 200 lines. Right. So, okay. Sorry. So what else did I defer for later? So it's Q5 and then. Oh, I think I didn't defer anything actually. Yeah. Oh yeah. So slicing is basically actually did I do slicing this year? I didn't, did I? Yeah, so let's not do it.
In one of the labs we needed to use.
Oh yeah. Yeah. So well, so like basically like if you have a list, you can say, I want the elements of the list starting from element 1 up to and not including, let's say, element 4 in steps of, let's say, 2. Right? So this means that you have element 1 and then element 3 because it's steps of 2. And it's up to but not including element 4. So in a way, this is equivalent to say, so if you want to get those elements, it's equivalent to saying for I in range 1, 4, 2, get me Li. Right. So this is again like I is 1 and then I is 3 and then up to but not including 4. So you're done. So that would also print L at 1 and then L at 3. All right. Are there like other requests that are not Q5 from 2015? Yeah. Well, I mean, you could have 2, you could have more. Yeah. Rima, yeah.
In 2016, question 6, it was about the question about the peaks.
Like a late question. So 2016.
Yeah. So in here, the way I read the code, or the way I read it, it's that I basically didn't consider, like I considered only I'm gonna sort my list and I'll see if, like basically what I'm trying to say is I didn't consider, like if I have a peak and 5 is going and then 3 and then 4, so technically here I would have 2 peaks because it's not decreasing like in the right order, which I did not consider. In the context of the question though, when we test every single list in the question, it would work. I know it's not the right answer though. So in that case, how many points could possibly be like deducted?
All right. I mean, like, it's not as if question 6 is going to reappear in exactly the same form in 2023. In order to know kind of, I mean, kind of the way you described it, if it works on every input, then the answer is 0 points would be deducted. I might not have understood something. It's also like, if you want to like send me a solution, I suppose I could grade it, but like it's not going to be very meaningful because it's not as if like this question is going to reappear, right? Or like not like exactly. Like also, if it does, just do the right one that doesn't result in any deduction. So yeah, but like the general philosophy is kind of, yeah, like sometimes there are difficult cases. I'm not sure that what you described is actually a difficult case. Like it might be that like the answer is just 0 points would be deducted anyway. But like sometimes there are 0 cases, and then it's like you got to look at the case and kind of decide. So the difficult case is if a person somehow like misinterprets a question, but in a sort of reasonable way, and then they do a question that's kind of difficult, but maybe not as difficult as kind of the actual question, and then it's a judgment call. But that's like extremely rare. I would not worry ahead of time about those kinds of situations. I mean, like it's not like they don't happen. They do, like once every couple of years to one student, but like there's bigger things to worry about usually. Not that it doesn't happen. Like it's not an unreasonable question. It's just unlikely that it would actually happen to any particular student. So, okay. All right. So Q5 from 2015. So the question is, call list almost symmetric. It could be made symmetric by swapping 2 of its elements. So we want to know whether the list rather is almost symmetric, right? So I want to start by doing kind of, is the list symmetric? So that's kind of a standard kind of question. I don't know if it's on coding bat or not, but a lot of the time you'll see this kind of thing. So is the list symmetric? How do you check? Well, I always kind of like, sometimes I myself don't start with an example, but it's good to just write down an example and say, okay, like this is a symmetric list. So how do I check if it's symmetric? So let's say the most straightforward thing is to say, okay, like is the last element the same as the first element? Is the second to last element the same as the second element, and so on? Okay. So how do I compare last element? First element.
Can I suggest something?
Sure.
Maybe you could do for I in range half of the list.
Yeah, exactly. So I'm gonna get to that. Yeah, but yeah, that's exactly what I'm getting to. Yeah. So so to compare that, I would check kind of L at 0 and L at -1, right? So this is the last element, and then this is the first element. And then I want to also compare L at 1 and L at -2. And I want to compare L at 2 to L at -3 and so on, right? So how do I do that? So like you suggested, so we'll say for I in range up to half the list, And then we'll say, if L at I is not equal to L at minus I plus 1, so initially this is going to be L at minus 1, then L at minus 2, then L at minus 3. Then we return false. Because if we find that like this doesn't match, for example, then we don't need to check any further. Something doesn't match, not symmetric right away. If we checked for I, like you said, up to half the list, then we can return true. So here there's a little bit, like it's a little bit subtle. You like this works, like you need to like maybe think about it a little bit. So if, for example, the list is of an odd length, like what's the last thing that you check? Well, the answer is the last thing that you check is 2 equal to this guy? And then you don't really need to check if, like, it doesn't matter what this value is in the middle, because for symmetric purposes, it's the same. So that means that it's fine that the last comparison that you make is between the element at 5/2 and the corresponding element on the right. So you would also check that if the list is even length, that this also works. And indeed it does. So you go up to element 4/2 minus 1. So this is this guy, and you check is this guy equal to this guy. But there is a subtlety here, which is like if you go up to 5/2 integer division, not including 5/2, then you won't compare 5 to anything, appropriately so. I mean, you could compare it to itself, but it's always going to be equal to itself. Right. So, all right. So that's
a question.
Yeah.
Oh, sorry for interrupting, but just I don't understand why length of L integer division 2 would result in the right answer, even if we had an odd list. Could you explain again?
Well, so I mean, like I just think about it in terms of like an example, and usually it works, right? So here, length of L is 5. And the last index on the left that we need to compare to anything is 1. So range of 2 would work, and 5/2 is 2.
Okay.
Right. And kind of the intuition is you need to go like up to the middle, but not quite the middle, because the middle you don't need. So, all right. Yeah.
So to understand, in order to start from the last element, we say minus. Why does it start? Okay, it starts -1.
Yeah.
-0 doesn't.
Yeah. -0 is just 0. Yeah.
Yeah. Okay. Okay.
So kind of the way I think about it is it's like for I equals 0, it's -1. So that's good. That's what I wanted. For I equals 1, it's -2. That's what I wanted. And then you increase I by 1, you decrease minus I plus 1 by 1.
So a negative in the list means that it starts from the end.
That's right.
Okay, from the end, we start always by -1.
Yeah. Well, so -1 is the last one.
Yeah.
Yeah. All right. So yeah. Yeah, that's actually an interesting question. So it so happens that there wouldn't be a problem, because what you end up doing is you'll just end up comparing things the other way. Like you'll compare, like first you compare this to this two, and then you'll compare when I is equal to 0, 1, 2, 3, you'll compare this guy again to this guy. So it's fine. It's just that you'll be comparing each pair twice. So, all right. So that's a symmetric. So now almost symmetric means that if you swap, it'll become symmetric, right? So how do we do that? So basically the idea is like this. We'll try to swap each pair of elements. And if that results in a symmetric list, then we'll return true. Right. So how do we swap each pair of elements? So here it's kind of the nested loop example where we list all the combinations. So we want to like look at all the possible pairs of elements, try to swap them, see if that results in the list being symmetric. If it does, great. If not, we restore the list back and try again. So I'll say for I in, so this is like not like that efficient, but I'm not going to bother with making it more efficient. So here, I and J are all the possible combinations of all the possible indices in L. So then what I'll do is I'll say, okay, swap elements I and elements J. And then, so this is like the usual swap. So I'll say Li is now the old Lj and Lj is now the old Li. So now I swapped, and then if the list is symmetric, great. That means that the original one was almost symmetric because we did one swap and that resulted in a symmetric list. So here, what I'll do is I'll like clean up after myself and do the swap again. It doesn't cost me anything. That wasn't required like when I was creating the midterm, but like it's not good to like mess up the list for it to become symmetric and then to return true without cleaning up and getting back to what it was. And if I tried everything, so if it's not symmetric, I'll again kind of clean up. Right, so I tried, is it symmetric? If it was symmetric, I just return true. Otherwise, I just restore my original list back by swapping again. And I'll just try again. If I tried everything and it's never became symmetric using one swap, I just return false. So it's kind of similar to what you had in the tic-tac-toe project. Lab problem, where you had to like try to put an X somewhere and then remove it back. So that was kind of the inspiration for this question is like, again, like you change the list a little bit to see whether that results in a symmetric list. If it does, great, you return true. If not, you restore the list to what it was before and you try again. And here is like, here you have the technique of trying every possible swap. So to get all the possible swaps, you need like all the possible I and J's that are between 0 and length of elements 1. So that's like not advanced, but yeah, okay, there is like, okay, so
Can I ask you a question?
Yeah.
What if, like, I don't know how this differs, but what if you went through the is symmetric thing and then see the element in which it makes it false and then swap that to see if it makes it symmetric or not?
Well, I mean, the question is, what would we swap it with?
Oh, good question. Yes.
So, and it's not necessarily that you would swap like the one that, so, I mean, you could do it, like you would have to try it with both the elements that are not equal rather than one. So, like I would say not worth it. You could give it a shot, but yeah. Yeah, Rima?
I just don't understand why we need a nested loop in this case.
Well, so what are we trying to do? We're trying to swap every possible pair. So what does every possible pair mean? It's like swap 0 and 4, swap 5 and 9, So like every possible swap, because that's the definition of almost symmetric, is according to like the handouts, right? So the definition of almost symmetric is if you make a swap, then it becomes symmetric. To know if it's possible to do a swap for it to become symmetric, you need to try every possible swap. So what we're doing here is we're trying every possible I and j, right? So like 0 and 0, 0 and 1, 0 and 5, 1 and 7. And we're saying, what if you swap 1 and 7? Would it become symmetric? So in order to get every possible I and j, we need for I in range length L, for j in range length L. That gives us every possible combination of different i's and j's. Does that make sense?
Yes, thank you.
Cool. So almost symmetric means if you do one swap, it becomes symmetric. That's just like it's not like an official thing. It's just like in the question, that was like the English words that they chose.
But we use like the function
Like I can like those hypotheticals are not like so like you can look at old marking schemes to get an idea for what the marking schemes look like. I can't really like it's difficult to answer like a particular hypothetical because usually it doesn't exactly say kind of what would be on the page. And like the grade would depend on what's on the page. The general answer, and I'm sorry I interrupted you, but like, it's really that like I get a lot of those questions and like the answer is always the same. It's like, well, depends on the situation. In general, if you get partway to a solution, yes, you would get some credit. How much credit? Well, depends on how, you know, depends on whether the answer that you wrote kind of makes sense or doesn't really make sense. So certainly, so I think, sorry, so before I interrupted you, I'm sorry, I should have listened to the end, but I think you were asking, like, if I didn't know how to do is symmetric, but I knew how to use is symmetric in order to get the answer. Is that what you're asking? Yeah, and the answer is yes, like you would. So kind of, I don't know if I think I didn't have the marking scheme for 2015, so I think I didn't post it. Maybe I did. No, I guess I didn't.
Sorry, but it was written in the question that it's fine.
More than half the points. Yeah, sorry.
I said it was written in the question that you can use it even though you didn't complete question 4.
Okay, yeah, there you go. Yeah. Yeah, so the answer is you would get like all the points in fact. But that's like specific to this, which required you to first write this symmetric. Yeah, thank you for that. Yeah, all right. For midterm 2020 Q5, why is the array L being changed both inside and outside when L isn't being? That stuff we haven't done yet this year, actually. The answer is you can change the contents of a list. If like with the contents of a list, like if you look at the Friday lecture, you'll see that sometimes lists can be kind of aliases. 2019 is actually like not me, so that's like someone else's question anyway, but it could be that they're aliases. All right, I think we should go home. Thanks for, so yeah, thanks very much. So I'll see you. So yeah, so like I announced, I'm actually gonna be wherever I said, I think GB 119 or something at 6:30 tomorrow in the evening. So yeah, we could do 6:30 in the morning as well. Actually, wake up at like 5 these days, but unfortunately, I don't want to, but yeah. Yeah.
Thank you,
All right.
Professor.
Yeah,
you, thank
yeah, thanks. Bye. Bye.
you.
Yeah. Bye. The oh, the notes. I wasn't gonna. I can if you like. Yeah. Yeah.